to. And just want to see our volume streaming levels, see how they're doing. Don't want to get them too high, so that sounds about right there. Just go a little bit low, below the red, so we're not going into the red, and that looks good right there. Good. Okay, maybe go down a bit, just in case. All right. Yes. Good. 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 Yeah. I have to test that. Yeah, but it doesn't sound like too. Okay.
So most welcome to this seminar held by VTI, where we are going to listen to inclusive crash safety. And before I give the word to our professor in traffic safety, Astrid Linder, to talk about this important topic together with Magnus Karemyr, who is one of the developers of the prototypes of the seat evaluation tools of an average female and an average male. I will give you, my name is Ellen Grumert. I'm a research director at Traffic Safety and Traffic System, and I will give you a short introduction before I give the word to Astrid and Magnus. So VTI, or the Swedish National Road and Transport Research Institute, is an independent research institute that focuses on transport in Sweden. And our main task is to conduct research within the area of infrastructure, traffic, and transport. And we also contribute actively to the goals of the Swedish National Transport Policy. We are around 240 employees, and we have offices in Linköping, Stockholm, Gothenburg, and Lund in Sweden. And our research covers both all modes of transport and many different transport-related topics. And we are an assignment-based authority under the Ministry of Rural Affairs and Infrastructure in Sweden. But our funding does mainly come from funding organizations, both in Sweden and also in the European Union. So I will now give the floor to Magnus and then Astrid to talk about this jumps. Okay. To talk about this very important topic, inclusive crash safety with virtual testing and the world's first female crash dummy. And this is a topic that Astrid has been involved in and dedicated to for many, many years. And today we are going to listen to the latest achievements within this topic, and it comes from the results from the European-funded project Virtual, where VTI and Astrid has been the coordinator. The project ended in December last year, and many important results came out from the project, and the project has gained worldwide attention. So Astrid has had a busy couple of months talking to journalists for different magazines, television programs, but also attending different conferences to talk about this topic. And now we are also very excited to hear about this topic in this forum. So please, Magnus, go ahead.
Coming now, yes. Let's go. From the core team of this project has been Astrid, of course, professor in traffic safety, and we have Tommy Pettersson sitting there, doing engineering work in the workshop and getting things right. We have Mats Svensson from Chalmers, professor in injury prevention, and me. I'm the designer of the dummies. Magnus Karemyr is my name. We will talk about inclusive crash safety and what we mean by that. In short, is about being able to study what happens to us in a car crash, regardless of gender and size. So with us here is said to be the first crash test dummy in the female version, and we will say that it's rather the first prototype of a seat evaluation tool. I will start with a short story about her, why she's here, and then Astrid will show you the hard facts. Okay, the dummy family. Everything looks all right in this picture, doesn't it? But I would say that there is someone missing here. Since the 70s, crash test dummies have been used for testing car safety. The most commonly used dummy has been based on the male size and weight. The female in this picture is actually a scaled-down male, 1.5 meters tall and 49 kilos. She represents the smallest 5% of women by the standard of the mid-70s. She's rather the 12-year-old daughter in the family. We know from injury statistics that women in car crashes is up to 3 times more likely to suffer whiplash injuries. Do we really have to wait for women to get injured to know this? Wouldn't it be better to get this info from testing before the cars and seats go into production? Let's go.
Thank you very much, Magnus. And I will start with giving you some facts and figures to why we have done the virtual project. See if I can get this to work. Yeah, we had the vision of the virtual project to be that by 2030, injury protection performances of new car will be assessed for both women and men. And by that you understand that this is not the case. And I will show you the details of that in a couple of your slides. But initially starting to highlight the benefits in addition to being inclusive, that we also then in new cars should be able to identify the best performing innovations when it comes to protecting us all. And also, of course, in improved safety for everybody. So, what is the situation? Here you see, let's see if I have a cursor. Yes, I have. I hope you can see the cursor. Can you? No? Okay, let's try this one then. There we are, right? You can see? Okay, in this slide you see the development of protection in cars. These are data from Folksam Insurance in a 10 years increment. So you have 80s, 90s, 2000, 2010, and 2010 to 2019. Any injuries, that's all injuries, severe and fatal, or serious and fatal injuries, fatalities, and PMI, which is permanent medical impairment. And what you can see is that we have had an improvement of safety of the cars, which of course is very, very positive for both males and females. But what you also see is that the difference between females and males are still there. We hoped a couple of decades ago that with the testing and the way we are developing our cars, that we would have achieved a situation where everybody was equally well protected. But we see that we're not there yet, and therefore there is a need to have us better represented in the assessment of safety. So to some figures when it comes to risk and odds of fatalities, because this is important to see the difference between head count, because when you do a head count, you would, for example, when it comes to fatalities, you would see that men are more oftenly killed in crashes as drivers than females. However, there are many really strong contributing factors to that that doesn't have to do with how the car performs, and that is speeding, driving under the influence of alcohol, and not wearing a seatbelt. So if you look at similar crashes, then you see a number of studies here during the last decades that had looked at fatalities or severe and fatal injuries, finding that for a number of different injuries that actually females are at higher risk of injury, given that the crash situation is similar. So this is one of the reasons for this work to be done. Another one is the whiplash injuries, and Magnus mentioned this before, where we know from the 60s and onwards, these are a number of publications from all over the world showing the risk of females in comparison to males. And as you can see here, which is quite uncommon in the scientific world, that you have so many studies showing the same thing, a larger risk for females than for males. So this was known some decades ago when we did the first average male dummy. We hoped that that one would really improve the situation for both males and females. So that was back in the 1990s. However, here is data from Kullgren et al., Folksam data, showing an evaluation of the latest and launched whiplash protection systems. And if you look at overall, look at the performance of a standard seat, a group of seats called reactive head restraints, and Will and the Whips, which is Toyota and Volvo seats, then you would see that yes, we have things have really improved. So really, this is what you see when you divide the data into females and males. So for the reactive head restraints, if any effect, it's actually negative. So all the protection for performances was gained for the males in this case. The Will and the Whips, they both increased the safety for both females and males. And this is what we should be able to assess in new cars. Data like this takes 10 years to collect, to get sufficient data in order to draw these conclusions. So Magnus mentioned that we have the adult dummy family, and the recent one is based on the data from 1983 by Schneider et al. And here there were a lot of volunteers that you measured in order to get the proportions and seated in car seats and so on. And they identified the small female, the mid-size female, the mid-size male, and the large male as the dummy family. However, the female never made it into the family. So in the current testing, and this is from frontal, we have the small female, no average female, an average male, and a big male. So this is the situation. And in side impact, we only have average male, and also in low severity crashes, and for low severity rear crashes, we only have the average male dummy. So I want to spend just a couple of slides on driving forces here, because sometimes I get the question, so why is this? Why are these models, why are not models of the female part of the population developed and used? And actually, if you look at the legislation, the UNECE, there are two different main legislations in the world. There's the FMSS that are used in the US, and then there's the UNECE testing. Here we have seatbelt test, frontal test, two different frontal tests, and side impact test. And in all these tests, it is required that you use an average male. And I will show you the wording. So it actually says in the seatbelt test that you should have a short torso which has a shape of a male, and also its weight and weight and size. and it's the R16 mannequin. And when you then look into the website to where Humanetics, who is selling this one, then you get this picture. So then you see how it looks. In the frontal test, there are two different tests. Here it says that you should use the hybrid 3 that corresponds to the principal dimension of a 50th percentile male, that is the average male. And it's the same in the R137 test. You could or can put the small female, as Magnus showed, in the passenger seat, but not the driver. And in the side impact test, in the same way, here we have the first 50 percentile male, and also which is the ES2 dummy here, and also the world SID 50 percentile male. That's the only version of the world SID. So here you can see that how clearly it is specified. And in order for this to be inclusive, of course, you should, after the full stop of an average male, there should be a continuation of that sentence saying, and of an average female. And you can read more about this in in this publication that I published together with a colleague of mine a couple of years ago, where we also looked at of the law in Europe and the gap between legislation and what the law says. So now we come to the virtual project. So here we address this gap, but of course taking a much broader stand than doing only a dummy. We had a focus on virtual testing, because that is where we see the potential of having a big array of different occupant sizes. So we will of course always be limited to a number of sizes in crash testing, and then go beyond that by using virtual models. And we did that in a project with an open source approach. So it's the full name is Open Access Virtual Testing Protocols for Enhanced Road User Safety. We ended a couple of months ago, and we had aims that you see correspond to also what was in our vision, to reduce loss of life and health on in road crashes, identify protective innovations, as I showed you with the data from Folksam, by using virtual testing and human body models of both an average male and an average female. Because it's not only when it comes to dummies that we have the average male as the norm. Also in the big area of what is called human body models. Details model of the human body has been developed as the average male, the small female, and the large male so far. And we do this by sharing all the knowledge. So open source and open access. See if I can get this one to work. No, I couldn't. So then I talk. Pardon? Okay. So here I just want to show you what is available open source. These are the human body models. They are called Viva Plus. It's average female, average male, as seated occupant, as standing. So we can use them as pedestrian or standing occupant in public transport, and as cyclist, as you can see here. And then we also have a number of features that you need to do the simulations, because it's not only a model of the human that you need also features to put these models in. And in addition, there are a lot of tools and scripts for how to use these models. So when using these models and compiling all the data, we wanted to show all the steps from virtual testing to verification of how it works in real world by developing the seat evaluation tools for the low severity, rare impact crash configurations where we have the risk of, in particular, soft tissue neck injuries. So then I leave the floor to Magnus, please.
Okay. As you saw briefly, the seat evaluation tools are part of a larger context. Virtual testing is one way to simulate and understand the human body in a car crash. Physical testing is another, with an important connection to research history. Two routes to the same goal. Okay, how do you start when you're designing a model of a human body? Crash test dummies are made to be durable, with simplifications for specific needs. For low severity crash testing, we need a spine capable of a human-like range of motion. We need a soft body to interact with the car seat. As Astrid mentioned, the BioRid was developed for 25 years ago to address testing in low severity rear impact. It has high detailing of a spine and neck with a fairly human-like motion. It's two-dimensional motion in the plane that you're moving. The shoulders of it are rigid, quite, and it's an average male. We want to go further now. The human body models of the virtual project are based on data from humanshape.org. And shown here are the average female and male in a car driving position. Same but different. When we compare these two, it's obvious that the body geometries interacting with seats are different. Of course. We've always known that. So this is the starting point of our prototype development. An example. We decided to use parts from standard crash test dummies where possible. But how do you make a female pelvis? Well, simply by cutting off the pointy sitting bones and add soft pads, both there and on the hip sides. So altogether, we have created a female pelvis. You see it on the right here. We found that molded polyurethane foam could be a suitable body material. It has a soft core covered with a firm skin. So all new parts were made this way. But what about the spine? We want a spine that's movable in all directions. Well, this is a linear vertebra, the base component of the lumbar spine. A flat steel spring handles the motion resistance between the vertebrae, and we have some rubber bumpers in between because we don't want metal-to-metal clashes, and we get disturbances in the sensor readings. Okay. And the mounting ears of the vertebra are perpendicularly rotated. So when you mount them together, you will get a stack of vertebrae which are movable in all directions. And then we want some rotation. We took the same concept and split the vertebra in two, added some bearings in between, and there you have a rotating vertebra. Putting it all together in a stack, we have a repeated concept with some design variations, with straight vertebra in the lumbar spine and angular and rotating vertebra in the thoracic spine. And here's the first ever movie of it. We tested the motion, and it seems to work. Now you see the rotation also. like that. On top of that, we have the cervical spine, the neck. It's inspired by the biorid system, but we have made it a more compact solution inside the head, with 2 springs pulled by wires to resemble the muscle strength, and also a oil-filled damper to smoothen out and dampen the motion. All driven by wires. And let's see how it moves. At the rear impact, you will get a retraction. Note the strained situation for the upper vertebra. It's squeezed from all directions. And then, all of a sudden, you get an extension of the neck. Then you're at the other end. And on top of that, you will flex forward. So it's not optimal for a sensitive system. Let's take a look inside. You see the limited amount of space inside a 5th percentile head. But we did fit the springs and the damper. And let's see now, if we make a retraction motion, you see that the springs and the damper are not affected. So this symbolizes the weakness we will have in our neck. It's an easy motion. When we make an extension of the neck, we get full spring load and the damper goes to its end position. So here is the chest. We see some test examples here. You see also the upper arm design, which is designed to be a more soft surface towards the seat for better interaction. See how it nicely fits into the chest. Inside the chest, you see a small sternum, which is very simplified. And onto that, we mount the movable shoulder system. So the entire mechanism is separate from the spine and freely movable. So we don't get any disturbances to the spine motion. You can also see the pins sticking out from the spine, which connects the soft body to the spine motion. So here you see the motion of the shoulder. You see also the pin that connects the shoulder motion to the soft body. Well, we make this in 2 versions, the male and the female, which almost the same parts included. We have some design variations to make it longer, and we have added the curvature of the male by simply modifying 1 vertebra. As you see that the neck is following the picture of the Vivipulus skeleton. It's hard to see in this picture. We go to the workshop instead. Putting it all together. Is it me? Let's see. Well, inside the dummy, we have 4 sets of sensors. They are combined gyros and 3-axis accelerometers. So all in all, we can read both motion and rotation at 4 locations in all directions. And we can also read the difference between sensors. So let's mount it together. The shoulder mechanism, and you see the hole in the chest for the connecting pin. And we're off. It's time for the first sled testing. Here you see the lab seat, which is has been used 15 years ago with volunteer testing. And our aim is to make the same setup with these dummies. See here, this is a test at 15 kilometers per hour. You see how the lab seat reacts to the dummy motion. And you also see what forces the neck is exposed to. Watch the neck here. You see that it's not the hit to the neck rest, it's the hit forward, which is the severe one. Okay. The initial testing of the sets were run with the same setup, as I said, that was used in the volunteer testing 15 years ago. In the lab seat at 7 kilometers per hour. That's a speed when you don't get any injuries, but you see all tendencies of it. And the results, well, these are made from video analysis because we want to use the same setup in detail. You see the light gray corridor are the male volunteers, and the dark gray corridor are the females. You see that to the left, you see the head X displacement. There is the movement of the head. You see that the female solid line almost follows the corridor. And you see that the male has a extended motion. For the next diagram, you see the T1 motion, which is down here. And there you see a bit weaker motion for the dummies. So all in all, we can say that, well, they have a bit too weak neck and a bit too stiff body. Things that we have to improve in the next coming projects. So, yeah, prototyping is all about learning. This is the first attempt, the 0.1, the set 0.1. The first attempt and a promising step onto the path towards inclusive crash testing. Here we see them on the picture in Saab seats, and you can notice the different location of the head towards the headrest and the shoulders towards the seat back. They are tightly connected to the data Astrid showed. Everything about the set development can be found in the report, which you can download from VTI website. And within the virtual project, there were 15 partners all over Europe, and everything we did can be available through the trust of TOW, which has been created, Open Virtual Testing Organization, the survivor of the virtual project. Feel free to read about it on auto.org and about the project at projectvirtual.eu. And that leaves us to the question to you. How would you use it? What can we develop? What new projects can be based on this? Thank you for listening.
And now we have some time for questions, right?
Yes.
Yep. questions? No? Yeah, I think it's important to distinguish between what we have been talking about here is evaluation of safety. And of course, we have many car developers that put a lot of effort into protecting us all, as you saw from the examples of when it come to how the seat protect us in a rear impact, which was the data from Fogsam. So I'm sure that the car manufacturers respond to our demand of safety. And if the regulatory tests are requiring to be inclusive, then the assessment will be that as well.
The body measurements were based on the population of US.
Yes.
Is there similar things being done in other parts of the world where perhaps the bodies are different sizes, or will the fleet of these cars never move around the world, like they will always keep in the western part?
No, they don't today. So and they won't tomorrow. I don't foresee that. So as you say, it's we are global in that respect. And there is a number of details here. I show you the study from Schneider et al. In 1983. And there you established the weight and the height. That was that approach was reviewed in leading up to the dummy world seat, which is an improved side impact dummy that was launched in 2000. And in establishing the dimension of that one, there was a look at how the population had changed from the 70s, and also how the population in the cars in particular had changed. And then you could see that in the Western world and we have became heavier and longer, but we also cars had also moved into other parts of the world where the population was shorter and lighter. So the average is quite a good estimate still in terms of height and weight. So that holds. Then of course the distribution will might shift a bit, but that's also encouraging. One of the driving forces for doing virtual testing is to be able to address more broadly. But of course, in order to you need a starting point to say shorter, longer, different properties and proportions, and that we have for the male, but not yet for the female. And the Viva Plus model, as you saw here, is actually the female one, is the first average female model done in the same way as the male. We did a forerunner to this. It was a Vinnova-funded project that we run in Sweden, where we modeled one individual, which is the same approach that has been done for the average male and the small female and the large male globally. So those are available. You can buy them. So all the data was available for the female. Nobody had made anything out of it. And then we built on that and made the Viva Plus models. So that now you have these two models, and you can start elaborating on what differences in distribution, maybe on different markets, would result in terms of the sizes and properties of the occupants. Is that sure?
Well, thanks.
So, please, would you like to present? Would you like to present yourself?
So, Kjell Simonsson, I'm a professor at solid mechanics here at
Oh, excellent! Yeah.
So a long time ago, 35 years ago, I started off as a PhD student, and I
for the online persons.
I had colleagues, you know, building car crash test dummies in.
Lars Gunnar?
Yeah, he was the professor at that
Yes.
time, and I had colleagues, Lars Fredriksson, who's nowadays in Altair, you know, building car crash test dummies at that time. And of course, I've seen what my colleagues now, for instance, at Dynamo here in Linköping, what they are able to, and I saw they were part.
They have been a very important part of this project. So you see where it comes from, right?
Yeah. But in a way, you get pretty amazed that there is still not available female test dummies, which is strange to say the least. Anyway, we are looking forward to your continuing work in this field, and we have also areas of research which touch upon things you do. So we hope we will be able to talk more about it.
I look very much forward to that. Thank you. A question or comment, please.
Okay, so I'm sure that the vehicle industry uses a lot of modeling and simulation in the design loop, but as far as I understand, the certification requirements for crash safety certification is fully based on physical testing.
Yes.
And a very limited number of physical tests.
In particular, the only test with the average male.
Yeah.
Yeah. So you don't even have to do more testing. You can actually put 2 dummies in the test. So yeah.
Yeah, and with virtual testing, you can do a lot of more variations.
Yeah, but you need a starting point also for virtual testing. So as you know, if you have a car model and you want to vary things, then you have to start with doing the car before you can start to vary it. And that's sometimes where we make a jump over that step.
Yeah, and my question is, what are the main benefits of virtual testing in this field, and what are the main challenges to establish virtual testing? Does the industry want this, or is it more of an academic interest, or what are the main challenges?
Yeah, very good question, and a very, very deep question. I will try to elaborate it and not be too long. We have, or the car manufacturers and we in society, we use, of course, virtual models in the design phase. But when it comes to assessing safety and assessing safety from, for example, here, different cars, then that's totally new. But something that we see a big need for, and we will always be limited to a certain number of dummies, and so this we do together with industry. So this is where we really join forces. It's academia, it's industry, it's developer, and there are many. So everybody's there, and that's maybe was a bit quick on describing the virtual project, but there we had seat manufacturers, Faurecia, we had car manufacturer Volvo, and we had Dynamo, and so we are all there, and in the roadmap for Euro NCAP, which is the consumer testing. I showed you regulation. Consumer testing, of course, goes beyond regulation, but it's also, of course, flavored by the regulatory test and then goes beyond that. The vision is that by, or mission goal is that by 2030 they should have entered into also using virtual testing in order to get a better resolution in the assessment of safety. So this is something that we work on globally. There is also there are global groups where we discuss this. Car manufacturers, developers, academia, everybody are there, and there is actually a suggestion for a informal working group within the UNEC, and that is then suggest the procedure in UN is that UN work is that you have somebody suggesting something, and then it's the contracting parties, which are the countries. That's the only one that can can vote. And so here Sweden has taken a lead. Sweden is sharing a suggested working group, and it comes from GRSP, and it's up for vote and has been recommended and supported by a high number of countries, and will be up for vote or decision in March. And that is addressing what we are talking about here, both virtual testing and how we can be more inclusive in our assessment of safety.
Thank you. So by 2030, who do you think will actually carry out the virtual testing? Will it be carried out by the car manufacturers or some certification authority?
Yeah,
And if so, will the car manufacturers agree to actually hand over simulation models of their products?
That is spot on, and these are the things that we need to solve. And of course, I think in order for everybody to trust the results, it will not be sufficient to get numbers from different car manufacturers, and they also should trust each other and the rating that they have received and their performance. So I would assume that the same ecosystem that we have for mechanical testing is actually needed for virtual testing. Thank you for the question. Okay, yeah, should.
Okay, so first question from Vera says, how long do you think it will take to have those testing regulations, including the female dummy?
Depends on how much effort we put into it. As I have tried, or we have tried to illustrate here, it's not impossible. It's not going outside our solar system with the humans. So, but it does require that we decide that we're going to do it, and then we do it.
Great. And next question, and it says, so when will the dummy be ready for industrial application on a large scale, and are there still issues that need to be addressed or any additional fine-tunes required?
Yeah, first of all, I think Magnus showed you some of the fine-tuning, and of course this is, as we have tried to be very, make sure that nobody misunderstand that, oh, we have, everything is done and so on. This is a prototype, but it is important, and it is a big step, right? So there are fine-tuning needed to be done, but in order to make it certified dummy, that's also why we call it a seat evaluation tool, because it is not a certified dummy, and that now we come into the testing and the procedure needed for testing in the same way as virtual testing, where you need to set that up and you need to have that specified. So that whole work again, needs to be done. We have done it for all the dummies that I showed you. So we know how to do it, but we need to do it.
And last question is do you consider pregnant dummies?
Yeah, that's of course an important thing to look at what happens to the fetus, and that has actually been done, but then it wasn't possible, of course, to put the fetus on a average female. So you either put it on the 12-year-old or on a male. So you can look at the fetus if specifically, and that has been done. But of course, that is all different aspects of occupant protection, and is of high importance.
Thank you. And thanks to questions online. Thanks.
Thank you.
Thank you so much, Astrid and Magnus. For those of you that are here and lucky to be seeing these all things live, you have now the possibility to go and look more into it and talk to Astrid and Magnus and also Tommy that is here, and ask questions, and please take the opportunity to do so. For the other ones that are online, we will now close this session. So thank you very much for listening, and thank you, Astrid and Magnus and Tommy.
Thank you.